Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 2-chloro-1-methylenepropene, which can be written as CH2 is equal to C, Cl, CH3. But looking more carefully at the structure drawing, it shows CH2 is equal to C with Cl on the carbon bearing the double bond and a methyl group. Actually, the structure is CH2 is equal to CCl. Wait, re-examining, the structure is a vinyl chloride type compound. The image shows a terminal alkene. The carbon bearing Cl also has A is equal to CH2 group. So the compound is CH2 is equal to C, Cl dash. But there is also what appears to be a methylene. Let me reread. The structure appears to be 2-chloro-1-methylenepropene, or more precisely CH2 is equal to C, CH2. Cl. Actually, from the image it is 2-chloro-1-propene type. The structure is CH2 is equal to C, Cl, CH3. No. Looking at the drawn structure, there is a carbon with a double bond to CH2 and also bonded to Cl with what looks like a methyl or CH2. The compound drawn is likely CH2 is equal to CCl, CH3 to chloropropene, or CH2 is equal to C, CH2Cl something. Given the answer is B, methyl bromocetate, BrCH2COMe, let me work backward. Moving on to the next step. Starting alkene plus Br to HBr plus P. This is a special reaction. The starting material appears to be CH2 is equal to C, Cl dash. The addition of Br2 to a vinyl chloride type compound can proceed with elimination of HBr. If the starting material is CH2 is equal to CCl2 or similar, Br2 adds and then HBr is eliminated. More likely, the structure is CH2 is equal to C, Cl, something that upon treatment with Br2 undergoes addition then rearrangement elimination to give HBr plus P, where P contains a Br and a carbonyl, since MeOH converts it to an ester. Moving on to the next step. If P is BrCH2C is equal to O, Cl, bromostyl chloride, then reaction with MeOH would give BrCH2C is equal to O, OMe, methyl bromocetate, which is answer B. And for the final step. The starting material CH2 is equal to CCl, CH2Cl, or more likely the structure is 2,3-dichloropropane or similar. Actually, the most consistent interpretation, the starting material is CH2 is equal to C, Cl, CH2Cl, 2,3-dichloro-1-propene. No. Given the image shows a terminal methylene, CH2 is equal to connected to a carbon bearing Cl and another substituent, and Br2 gives HBr plus P, then P plus MeOH gives methyl bromocetate. If starting material is CH2 is equal to C, Cl, with an additional CH2 group making it CH2 is equal to CCl, CH2. The most logical pathway, CH2 is equal to CCl2 plus Br to CH2 Br, CCl to Br, HBr CHBr is equal to CCl2, or alternatively the compound is a ketene equivalent. The key is P must be BrCH2COCl, bromostyl chloride, because BrCH2COCl plus MeOH BrCH2COMe plus HCl, giving product Q is equal to methyl bromocetate, option B. A. Would require no Br incorporation in product. C. Methyl acetate has no Br and doesn't account for Br2. D. Has no Br and wrong connectivity. Therefore, the correct answer is B. Therefore, the correct answer is option B.